what we have here is an exponential growth function. All right. Don't copy down what I'm going to do right now. You're going to have something that looks, an exponential function is going to look like this. Okay. It's going to look kind of like a parabola, except it doesn't go up on the other side, it flattens out. Okay. We'll get to graphing later. All right. The values here, you're going to have two values in your function. Okay. There's an A value and a B value. The A value is an initial value. Okay. This means something that you're going to start out with. Okay. A lot of problems we're going to talk about are going to deal with money or population, or it could be bacteria. And the problem might start with, I have $500. So that would go here. Okay. The population of Afton is 3,800 people. That would go right here. I have 150 bacteria in a petri dish. That number will go right here. It's what you start out with. Okay. Now the B value is known as your multiplier. Okay. Multiplier is going to describe how fast something grows. All right. A lot of times when we do this, it's going to be a percentage. All right. And the determination of whether it goes up or comes down will depend on this B value. It's going to be what we call our growth or decay multiplier. Okay. If this B value, if B is greater than 1, we'll have growth. Okay. If B is less than 1, we'll have decay. Okay. Problems that we deal with like decay often have to do with like cars that depreciate over time, populations of cities that are declining, like maybe way up north in the Iron Range, population is losing 3% per year, things like that. Growth problems, money in a savings account, expansion of a city and of up-and-coming city, things like that. Bacterial growth, it's doubling every hour, things like that. Okay, your homework is broken up into 3 parts. The first part, we're just focusing on the multiplier. So I'm going to erase this right now. Okay. So the first part of your homework, we're only working about the B value. Okay. Now, the B value for percentage growth. Or decay. Okay. If we have a growth problem, we're going to take 1 plus the percentage written as a decimal. This is for growth. I'll explain this here in a second. For a decay problem, we'll take 1 minus the percentage as a decimal. For decay. I'll give you a second to get that written down, and then we'll go through about 4 or 5 examples. All right. So for example, this is our first 6 homework problems. They're going to use percentage growth problems, and then they're going to use some words that we'll talk about in a second. All right. So for example, it says I have 8.3% growth. And the directions are to find the multiplier, find the B value. Okay, to find the B value, we're going to take B is equal to, because I said growth, okay, they're going to use the words growth or decay. We're going to take 1 plus. Okay. Now, how do I write 8.3% as a decimal? How do I convert percentages to decimals?
You moved the decimal 2 to the left.
We move our decimal 2 to the left. So in this problem, I'm going to go 1, 2. Well, now I'm missing a number here, so I have to put in a 0. I'm going to put in 0.083. So pretty good. Now, I'd like you, without using a calculator, to add 1 plus 0.083. We want to take a chance on that one. No calculator needed. Here we go. Everybody got the tricky answer to this one?
Someone said it in the chat.
Oh, dang it. Let me take a quick peek. I'm guessing they're right. Nailed it, Becca. Good job, buddy. 1.083. All right. All right, you guys try this one. I'm going to put 22% growth. You guys do that one while I grab my attendance sheet quick. All right, I had to grab my attendance sheet. Everybody got the answer?
$1.22.
1.22. All right. Trying to trick you a little bit. There is no decimal here, but you guys are smart enough to realize it's right at the end here. So I'm going to go 1, 2. So B is equal to 1 plus 0.22, which is 1.22. Okay. So do not write this part down. This is not part of the first 6 problems. In your function, you'd have some starting value. Making one up right now, $500. And then you'd put one of these two numbers, depending on what the problem is, would go right in here with an X value. That's what your problems are going to look like in the bottom half. Then in the bottom half, we're going to start plugging numbers in here. Okay, now let's do some decay problems. All right, let's do 16.4% decay. Okay. Now in decay problems, we said we're going to take 1 minus that percentage as a decimal. So see if you guys can find this one. All right. Anybody think they have this one?
0.836.
That sounds about right. So I'm going to take my decimal that's right here. I'm going to move it 2 spots. And now I have a decimal that's 3 digits long. 1 minus 0.164. And I will get 0.836. That is correct. All right. Last one of this section. Okay.
Wait a minute. Sorry, I have a question.
Yep.
So if it was a growth, we went to the left, but if it's a decay, we still go to the left?
Yep, because that part of it, you're just turning a percentage into a decimal.
Okay.
Okay. The growth or decay depends on what you do with number 1. The one itself stands for 100%. Okay. So if I add a number onto 100%, it'll go above 1. If I add a number, subtract a number from 1, it'll go below 100%. So it's going to get smaller. All right. Let's do 7% decay. All right. Anybody want to take a crack at this one? 1 minus some decimal. Jaden, how about you?
Sorry, 1 second.
Yep, no rush.
0.93.
You got it. All right. So once again, the decimal's here. I move 2 spots. I got 0.07. 1 minus 0.07 is 0.93. All right. Almost done with the first part. Now, sometimes they don't give you a percentage. Okay. So B values that are not percentages, they're going to use words. And they're pretty easy to decipher. Oh, so I'm going to take one of those last problems here, one of those decay ones. Okay, G of X, I'm just making up a new letter, new equation. I'm going to start with 3,800 people. Now, last one we had 0.93. Okay. This is what the equation might look like. Once again, these would be starting values, but these are those B values. Because this number is larger than 1, I know it's growth. Because this number is less than 1, I know it's decay. All right. Last part of the first section. B values where they don't use a percentage. So they're going to use words like doubling, tripling, quadrupling, halving. Okay. So in these 4 cases, they no longer use a percentage. They just give you a word. What do you think the B values are going to be for these? These are not tricky. Don't let them confuse you. What do you think the B value is of something that doubles?
Two.
2. Super duper tricky. Okay. Tripling. How about Haley? What do you think tripling the B value is going to be?
3.
3. All right. Tyler, quadrupling.
4.
4. All
Yep.
right. Having. Santi. Santi, you there? All right. Bella, how about you? What do you think halving is going to be? All right, Nick, how about you?
Half.
Half. Yep. Half. Okay, so you're going to see words like this. These will be the B values. They don't use percentages. So this is problem still 1 through 6. Okay, there's 4 B values up here. Which 3 are growth? 2, 3, 4. Which one's decay? 1/2. All right, so this is part still the top 6 problems. Okay, I'm going to make 2 more equations over here. 17, 3 to the x power. M of x. 112, 1/2 to the x. So now in the middle part of your homework, they're going to give you problems like 7 through 9 it would be. Yep. Okay. They're going to give you a bunch of functions just like these. And they ask you, is this a growth function or a decay function? And what determines that? If the number is
Over or under 1.
over or under 1. So let's just go through the list here. This first one, growth or decay? Shout them out.
Growth.
Growth. 1.22 is greater than 1. G of x, Abby. Maya, how about you? 0.93, growth or decay?
Decay.
Decay. Okay, H of x, Jocelyn, growth or decay? Okay, Ella, you want to help her out here?
Growth.
Growth. Thank you, Becca. Larger than 1. Okay. Last one here. Trudy, what do we got here? Last one. Growth or decay?
Decay.
Decay. Less than 1. Good job. All right. That's covers problems 7 through 9. That's all you're doing. All right. Last part of your homework. Like I told you, today is going to be the easy day. All right. They're going to give you a function. F of x. Let's go 82. Let's go 1.21. Then we'll put an x in here. So once again, we're going to have a number, variable, variable. And then they're going to say find f of 4. So what are they asking me to do when they say find f of 4?
Do you replace the 1.21 with 4?
Not the 1.21. Look at what we have here. What is this thing the same as?
The x.
The x. Yep. So we're going to put the 4 in place of the x. We're going to go 82, 1.21 to the 4th power. Okay? This does not mean 4 times f. This does not mean 4 times the equation. This is saying, hey, this is the letter f or x. So wherever there's an x, I'm going to put in a 4. All right. And now at this point, you are simply doing PEMDAS. Okay? So I have multiplication going on right here. I have an exponent right there. Which one should I take care of first?
Exponent.
Exponent. So you guys finish this one up. Make sure you're showing your work if you want credit on your test. I'll give you about 30 seconds, and then we'll do one more problem, and you'll be done for the day. All right. So on my graphing calculator here, I'm going to type in 1.21. And then right up here, if you're using a TI, there's a little caret symbol. Your calculator may be an XY button. I'm going to type in a 4. Now, here's what I want you to do to be accurate so that we stay consistent. I get a long decimal, 2.143588881. On your paper, I want you to round that number. So to show your work, if you want credit on test day, you're going to write 82. Then on my paper, I'm going to round this to 2.14. I'm going to round it to 3 digits. Okay? Just beyond the 4 was a 3. It was 2.143588881. Okay? So I go to my 3rd spot right here. If this number is a 5, I'll round up, but it's below 5, so I'm going to leave it. Okay. But in my calculator, I'm not going to do anything with that decimal. I'm going to leave it long. And now all I'm going to do is I'm going to hit the times button. And then if you look at my calculator, it's going to say ANS. That means previous answer. So that big long decimal's in there. Now I just hit times 82. All right. And I get an answer of 175.7. Actually, I should round that to 8. Now, I want to go back to the original equation. What was our initial value? How much of whatever we're talking about did we start out with in this problem? If I look at my original function, what are we starting with? Not the multiplier. What are we starting with? We started with 82 people, $82, 82 bacteria. All right. What did we end up with when we were done? We ended up with 175 of whatever we started with. Does that make sense? Okay. Because this number was larger than 1, this number went up from 82. All right. I'm going to give you guys one to do right now. Last one of the day, we'll go G of X. Let's start out with, let's say there's approximately 35. No, let's go. Let's say there's approximately 1,400 people living in War Road, Minnesota, and the population is declining by 7%. So our multiplier is 0.93. Okay, so that's my function. Now I want you to tell me how many people will be there in 6 years. So that means I'm going to plug in 6 for G. All right, you guys do this one, and you'll be on your own after we finish this up here. All right. Anybody need more time on this one? So, starting out with some small town, we have 1,400 people, War Road, Minnesota. We are decreasing by 7%. We took 1 minus 0.93. And we want to find out how many people are going to be in there in 6 years. So, I take my calculator, 0.93, raise the 6th power. If you don't know how to do that in your calculator, stay on after class. I'll show you how. I'm going to get 1,400 people. I'm going to round to 3 spots. So I'm going to round to 0.647. 0.647 is what I got. It was 0.6469901,834. Now I simply hit times. That'll take the previous answer and multiply it by 1,400. And we'll have approximately 906 people. Now there is a decimal that goes on. It's the actual answer was 905.786. But because I'm talking about people, we are never going to have a 0.7 or 0.8 of a person. So I'm going to round to a whole number if I'm doing a person problem later on. Okay? This time the digit after it was larger than 5 or larger. So I rounded up to 906. Any questions before I finish off attendance for today? All right. These are the people I am going to mark absent. I do not see Braden, Zach, or Michelle. All right.